Hi, everyone. Welcome to today's tour. We will get started in about 1 minute and give everyone a chance to settle in. Hello, everyone. Welcome to today's virtual tour of our joint water pollution control plant, one of our largest, or our largest wastewater treatment plant. My name is Genesis Rodriguez. I'm a public affairs specialist, and here with me you have Steve Krai, who's our joint plant manager. We're gonna go over today the age-old question, where does your sewage go? So every time you flush the toilet, what's the life that it takes after that flush? So before we get into the presentation, just a few things. If you have any questions, you can use the raise hand feature and we'll call on you, or also you can just use the Q&A. So the Q&A feature is located at the bottom of your screen. So use the Q&A and we'll answer the questions accordingly. And I think that is it. So questions, raise hand feature, or the Q&A. And with that, I'll stop talking and I'll leave it all up to Steve. Off you go.
Okay, thanks, Genesis. Hi, my name's Steve Krai, and I'm the plant manager here at the Joint Plant. Thank you for joining us this morning. We'll be doing a virtual tour of the Sanitation District's Joint Water Pollution Control Plant, followed by a tour of the Bixby Marshland. In fact, the Bixby Marshland is actually open right now. It's open from 8 to noon, the first Saturday of every month. Okay, I'm going to go over some general information first, and then we'll talk about the specifics of the treatment plant. On this slide here, you can actually see our service area. It's the white area, goes from in the LA Basin here from Pomona all the way out to the South Bay and down to Long Beach. And then we also have plants facilities up in the Antelope Valley and the Santa Clarita Valley. About 85% of our wastewater is from residential sources, such as from your kitchen sink, showers, toilets, and washing machines. And the other 15% is from industrial sources, such as refineries, paper mills, plating and dyeing companies, and breweries, things like that. So here's our mission statement. Our treatment plants have evolved into resource recovery facilities. Currently, we reuse about 25 million gallons per day of water on site. And since 1962, the districts have been recharging groundwater at our upstream water reclamation plants. The sanitation districts were formed in the 1920s to build the sewers and this plant to collect and treat wastewater in the LA region to protect the public health by keeping raw sewage off the streets and sending clean water to the ocean. This plan here, this map here shows the locations of our wastewater treatment facilities. And you can also see in the box there the details of the district's governance. We serve 5.5 million people in LA County, while the city of LA serves another 5.5 million people. The sanitation districts own and operate and maintain the large diameter trunk sewers, while individual city public works departments take care of the smaller local sewers. This photo here illustrates the size of these sewers. We have 1,400 miles that we maintain, that we clean, inspect, and refurbish as needed. Got another map here of LA County, and this shows first the city of Hyperion, the city of LA, with their Hyperion treatment plant, which is equivalent to our joint water pollution control plant as far as size and treatment processes. And then the other triangles show their smaller water reclamation plants where they do recycled water, where they reuse the wastewater for irrigation and on parks and golf courses, things like that. And here's the sanitation district's facilities. You can see the two plants up in Antelope Valley. Each of these plants, Palmdale, Lancaster, they treat probably about a little over 12 million gallons per day. Up in the Santa Clarita Valley, you've got Saugus plant's a little over 6 million gallons a day. Valencia, about 14 to 15 million gallons per day. And then down here, you can see the joint outfall system, we call it here in the LA Basin. And this system is all interconnected. We've got 6 upstream water reclamation plants that treat combined between them about 120 million gallons per day. And then here, the joint water pollution control plant, which I'll talk about in more detail in just a moment. We treat about 250 million gallons per day. And you can see the large trunk sewers that connect everything. And then the purple dots, those are our pumping plants. It's a gravity system for the most part. But wherever there is a low point, that's where we have a pump station to pump the water up and over a hill. So it can continue gravity flowing to a plant. What's unique about this system too is all the solids generated from the upstream plants are actually put back in the sewers downstream of those plants and flow down to our plant here in Carson. And so we're actually treating the solids for about 400 million gallons per day. We also have an extensive industrial waste pretreatment program. And this is to take out heavy metals, volatile organic compounds, and other contaminants at the industrial sources. Here's a view of the plant site itself. It's about a 300-acre site. The blue area shows about 220 acres. That's our operational area. And then we have buffer property around the perimeter, about 160 acres. And as you can see, the plant's been here since 1928. Our rated capacity is 400 million gallons per day, and we're right around 250 million gallons per day. So here's another view of the plant. Here's the administration building. If we were able to meet in person and do a tour, hopefully next year we'll be able to meet in person. This is where you would come and we'd start the tour here. This shows you the major cross streets around the plant. And then the 4 areas I'm going to talk about in some detail today are primary treatment, secondary treatment, solids processing, and the power plant. And then also later at the end, we'll talk about the Bixby Marshland here. You can see the parking area up here. Just off Figueroa Street, there's a little driveway entrance there. That's how you would get to that facility. So as we go through today, we'll take breaks periodically throughout the talk here. So as questions come in, I can answer questions. So that was it for the introduction. And Genesis, do we have any questions yet, or should I continue on?
You can continue. There's one that I think you're going to answer later on.
Okay, sounds good. Okay, so first we're going to talk about the water flow and how the water flows through the plant. Essentially, the treatment plant was designed to duplicate nature in cleaning water. We've got primary, we got screens that come in first, then pumps to lift the water to flow through primary treatment. You've got grit chambers, I'll talk about all these areas in a little more detail. The primary treatment, which is basically just a physical settling process, we pump over to secondary treatment. And that's a biological process. There's a lot of dissolved organic material in the wastewater that we are able to treat in the biological process. And there's actually a way we can measure that. It's called BOD, which stands for biochemical oxygen demand. And the way to think of that dissolved organic material is to think of if you take a glass of water from your tap and you take a couple teaspoons of sugar, mix it in and stir it up, that sugar is going to dissolve. So when you look at that water, it looks clean and clear and there's nothing in there, but there's actually a lot of dissolved organic material. It's sugar, it's food, and it's food for microorganisms. And that's something that as we do wastewater, we want to take that out so that there's no impact on the receiving waters. And then down below here, we send the solids to digesters, and I'll talk about the solids later in the presentation here. So following the water into the plant here, we have 3 main sewers that come into the plant. And we have 3 bar screens on each sewer. And these screens have 1-inch spaces. And as I said, we've got sewage coming as far away as Pomona. So this is one of the most odorous areas of the plant. And you'll see some overhead piping, that's fiberglass piping for odor control. This is what a bar screen looks like in schematic here. It's got a continuous flight and chain that goes up and down. And these brown bars here, these are actually rakes that rake the material up and over into a trough for further processing. This shows you a clean one when we've taken it out and refurbished it. And there you can see the chain that goes around, and then the rakes push the material up. And this is what it looks like when it's dirty, when we first take it out. As you can see, it's there's a lot of rag material. So now for a public service announcement. Disposable wipes are our biggest issue, not just here, but throughout the world for wastewater collection systems. They don't break up like toilet paper. So please don't flush the wipes, even if the box says flushable. So downstream of the screens on the left side here, the water flows through, and we have pumps underneath these right angle gear drives that lift the water and allow it to into this channel here. And then from here, then gravity flows through the rest of the primary treatment process. And again, you can see some of the odor control ducting, all the above ground piping here. This is all odor control piping. Next step of the process is a grit chamber. This is where we move grit, rock, sand, other inorganics, and we add air to keep the lighter organic material in the water in solution, so that the rocks and sand and everything settle out and get separated. I'm going to show you a video here, fly over the primary treatment area. As we come in here, we're following the main sewers in. You can see the bar screens area here, which I showed you in the earlier photo. Behind that are the pumps that then pump it into the inlet channels, and then the grit chambers. We have a couple of grit chambers on the right side, a couple of grit chambers on the left side here. And then into the bulk of the process here, where we have our primary treatment sedimentation tanks. We've got 52 tanks. The water's flowing from east to west here. Takes about an hour and a half to flow through here. And then the idea is we slow the wastewater from about 3 feet per second to 3 feet per minute. And that allows about 75% of the suspended solids to drop out of solution and about 50% of the BOD. Oops. And then if we were able to look under the covers, you could see here inside a tank, these tanks are about 10 feet deep, about 300 feet long. The solids that settle to the bottom are pumped to digesters. And then the skimmer here, you can see a skimmer flight that right here that pushes floatable material to the end where it gets pumped out. And that collects fats, oils, greases, and other floatable material. And that's also treated in our digesters. All right, Genesis, that's probably a good place to stop. If anybody has any questions about primary treatment, grit chambers, bar screens.
No.
Okay.
There are a few questions I think we can answer at the end.
All right, sounds good. So our next step of the process here is a biological process, and we call this our high purity oxygen activated sludge process. And we have 8 reactors, each one rated for 50 million gallons per day. And these are covered reactors. So they're in pairs. You can see a couple pairs there, a couple pairs there, and so on. Basically, you have a covered reactor, and that's where the primary effluent mixes with the microorganisms that we have to treat the water. From there, it flows out into these clarifiers, the top of your screen. And these are, we've got 26 for each reactor. And it's about a couple hours of treatment time in the reactor, and then another 3.5 hours in the clarifiers. And the purpose of the clarifiers is to settle out the microorganisms. And then there's a little pump station here. And those microorganisms are then pumped back around to the front and continually recycled. And I mentioned earlier, high purity oxygen. So this is the facility where we get our oxygen. We take ambient air and we cool it, liquefy it, and then it's a distillation process, very similar to what you have in the refineries. And we separate oxygen and nitrogen based on their boiling point. So these operate at about -300 degrees. We boil the nitrogen off because it boils at a much lower temperature than oxygen. And then we use that high purity oxygen in the process. I mentioned microorganisms. These are a few of the microorganisms that we use in the process. You can see the amoeba, flagellates, stalk ciliates. We have a lot of those. And then also some rotifers. These are aerobic organisms, and they're very hardy organisms because we, like I said, we use the 98% pure oxygen rather than just ambient air of the 21% oxygen. I'll show you a flyover here. The oxygen is actually pumped into the headspace here. And then underneath these gearboxes, there's a shaft connected to an aerator, which is on the surface. And that turns and creates a lot of turbulence for oxygen transfer in the reactor. And then here we're flying over the clarifiers. And this is where the water flows into, and the microorganisms settle out and then are recycled back to the front of the reactor. So this shows you, I showed you a lot of pictures of stuff, but this is essentially what we're doing. We're taking dirty water, raw influent sewage, and producing clean water out the back end. We want to try and minimize any impact on the receiving waters. One thing I will mention too is this secondary effluent. Up at our WRPs, our water reclamation plants upstream that I showed you in an earlier slide, they've got a tertiary sand filter process after the secondary process, and then they do reuse that water for parks, golf courses, groundwater recharge, etc. And we have a permit for our discharge into the ocean and analyze probably nearly 27,000 various parameters over the course of a year. We've got a picture here of a display we've got in the plant showing the water and what it looks like when it goes out to the ocean. It's disinfected with bleach, sodium hypochlorite. It's about 12.5% concentration, so over double what your household bleach is, which is about 5%. And then that effluent flows through the tunnels here out to the ocean. It takes about 3 hours to get out to the ocean. And by the time it gets out there, the chlorine residual is dissipated, so there's no impact on the ocean environment. As you can see, these tunnels have been in service since 1937 and 1957. And they are connected to the outfalls. We have 4 outfalls, 2 closer to shore, more shallow. And the 2 that we currently use are the 90-inch over here and the 120-inch. And you can see the diffuser ports at the end. It's a solid pipe all the way out, and then diffuser ports at the end. And that's 1.5 to 2 miles offshore, about 200 feet deep, so that we get about 166 to 1 dilution. And it's right at the edge of the continental shelf right there, if anyone is familiar with the Pacific Ocean out there. We also have a marine biology group that does very extensive monitoring of the ocean environment to make sure that there's no negative impact from our effluent. They do water column and fish and sediment sampling, and have just a very comprehensive monitoring program. And actually, we had a tour a couple of weeks ago, a virtual tour with that Ocean Sentinel, and you can see that on our website. If you go to the education tab, look for tours, and then you can watch the recording of that if you missed that. That was a few weeks ago. Okay, so I mentioned the 2 tunnels have been, existing tunnels here have been in service for the last probably 60, 70 years, continuous service. We haven't been able to take them out to inspect or refurbish or anything like that. So we've got this Clearwater project. You can see the details on the left side here. Construction started a couple of years ago here at the plant, and they'll be putting in a new tunnel, the green route here, all the way out to the coast, and will connect into the existing outfalls. Once that tunnel is put in service in the 2027, 2028 timeframe, we'll be able to take the existing tunnels out and then repair them and refurbish them as needed. As you can see, this route is a meandering route. We tried to go perpendicular over known earthquake faults, and also tried to stay in the public right of way under streets and things so that we didn't have to go under anyone's homes. Here's what the access shaft and the construction looks like now. That's the shaft hole is right here. And then this opening here, coming here to the north, is how it's going to connect into our plant eventually in about 5 years. Off to the left side here, you can see our cutter head, and these pieces are the hydraulic rams that push the cutter head against the wall during tunneling. And then these other pieces back here, and then up on the upper right, that's the trailing gear where all the ventilation systems and also the soil removal systems will be as they tunnel. And this is going to be electrically powered. And show you some pictures here. This middle one shows you how it looks when it's all put together with the hydraulic rams pushing the cutter head against the soil. And then back behind it is all the trailing gear. And this is, when it's put together underground, it's over 100 yards long. It's a pretty impressive piece of equipment. You can see On the right side here, this is when they're putting the cutter head together down in the access shaft. You can see somebody in here in the orange. That's the control room right back there. They also have that access here with the stairs and ledges and more stairs so that they can actually work on the cutter blades when they're many miles underground there. On the left, lower left here, you can see the how they're going to push it in, and it's going to be on these rails as it moves down the shaft, and you can see the end of the shaft here. They built its starter tunnel, and then they're just in the process right now of putting the tunnel boring machine together to begin tunneling. I've got a video here showing the launch from a few weeks ago, if you missed it. Highlights.
Good morning and welcome to the launch event for the Clearwater tunneling machine.
Investing in aging infrastructure is critical for the region and critical to protecting the environment. This is a once-in-a-lifetime type of project. We're pleased to be able to share it with you, and we're excited to be on the verge of the tunnel boring machine starting its work.
This is really exciting. I had no idea what to expect. It's really quite overwhelming. As Californians, we enjoy a great standard of living, in large part due to the quality of our infrastructures. This project is an investment in infrastructure to maintain that standard of living and preserve the environment for our grandchildren, of which I will contribute 30.
The Clearwater Project is an important project to protect the waters of Southern California. This project is not only about water quality protection. The sanitation districts have also committed to hiring local workers. And as we know, this project will provide jobs and pump hundreds of millions of dollars into our economy.
We've acquired a state-of-the-art tunnel boring machine, custom built for this project. We believe we have the right machine, we have the right plan, and definitely the right people.
What you saw behind the podium, behind Robert and Brian, was the cutting head of our tunnel boring machine. If you look over my shoulder, this is the backside of the front of the tunnel boring machine. Now we're at the second stop. This is called the trailing gear. Think of it as housing a little city that supports the front of the TBM.
But now it's my pleasure and honor to formally introduce Rachel, our tunnel boring machine. The machine is built to slowly carve its way through soil and rock deep below the ground without interrupting our daily life in the community above.
It is my privilege to recognize the finalists from the Clearwater Tunnel Boring Machine Naming and Art Contest. I actually want to thank all of the students who participated and made the contest a great success.
Thank you to all the children that participated of all the grade levels. We really appreciate your participation, and particularly Dagny, Ashanti, Emily. Congratulations on having your pictures on the side of this awesome machine. Thanks again.
All right. Genesis, do we have any questions at this time regarding that?
Yeah, regarding to the tunnel boring machine,
Okay.
Dwight Malema asks, how can the tunnel machine turn corners, sorry.
That is a great question.
And we have,
What's that?
we actually have one of our experts on the line,
Oh,
Glenn Acosta.
okay. Do you want to have him
Glenn
answer?
Acosta is our lead engineer in this, the Clearwater project. So Glenn, could you please answer, how can the tunnel machine, actually, one moment. Hold on, I just
Sure.
promoted you to panelist, so you can turn on your, okay.
Are you there, Glenn?
Yes, can you hear me?
Yep.
We can.
Okay, so the tunnel boring machine has hydraulic jacks essentially to push it forward, and so you can use those to turn it a little bit. You also have the walls that you put up, the segments, and you can arrange them a certain way to give it, to make the curves. So, and the front of the TBM actually has ability to turn a little bit. So with all those three things together, you can make the turns. Now, it's not going to be a sharp turn. It's going to be a very easy, gradual turn.
Yep.
Awesome. And then one more question for you, Glenn, before you leave us. Is that, actually, don't leave us. Is that the same TBM that Metro uses for subway construction?
It's a similar technology. Ours is, it's a slurry TBM. So we mix water and clay together to send that mixture to the front of the TBM behind the cutting head. Whereas the Metro TBM is where it digs and it takes the dirt and puts it on a conveyor belt, and that gets taken out of the shaft. So same technology, so just slightly different in terms of how you remove the soil.
Okay, awesome. Thank you, Glenn. All right, we will move on, Steve, with your presentation. And sorry, I had to stop sharing so that we can see Glenn's face more clearly. All right.
Good.
Here we go.
Where are we? All right. Let's see here. Okay, can you guys see that? We're
Yeah.
good? Okay. All right, so moving on. The next big project that we've got going on that I'd like to talk about is our regional recycled water project. As I mentioned earlier, our upstream water reclamation plants that treat about 120 million gallons per day, they reuse the majority of that. And then our water here, down here at this plant, our effluent has some nitrogen in it, ammonia, that we would have to remove. And then also, because of our industrial discharges, we have quite a bit of salt. So to remove that requires additional treatment process. And that's what this regional recycled water project would do. And this is a joint venture with the Metropolitan Water District of Southern California, and where we would take our effluent, clean it up to drinking water quality, and then be able to reuse that. And so we've got a 500,000 gallon per day demonstration plant at our facility. This is where it is. And then on the right side here, this is where we would build a full-scale plant to treat up to 150 million gallons per day, ultimately. And again, we've have separate presentation on this on our website if you're interested in that. And ultimately, it'd be like a $2 billion project to build this advanced water treatment plant. This is what the demonstration facility looks like. In these tanks here, this is a membrane bioreactor. It's a biological process. And this is where the nitrogen is removed. And then the water is routed underneath the tent to reverse osmosis membranes. And that's where the salt and any other contaminant, trace contaminants are removed. And then there's a UV disinfection and advanced oxidation process for disinfecting under the tent here also. There's essentially, a finite amount of water on the planet, especially in Southern California. So it really makes sense to recycle and reuse what we can. So if we can take 150 million gallons per day that's currently going out to the ocean and reuse it, that's definitely a good thing. This shows you how a full-scale plant might look with the biological nutrient removal here, where the nitrogen's removed, followed by the reverse osmosis, UV disinfection, and then a pump station to pump the clean water to where it needs to go. And where it would go is there's spreading basins along the coast here for saltwater intrusion, and then also spreading grounds for groundwater recharge inland and up in the San Gabriel area. And then ultimately, we could actually do direct potable reuse where this water was piped right to the drinking water plants that MWD has at the Deemer plant or the Weymouth plant. And this project, it's currently in the planning phase, and we're working on the environmental documentation now, and then we'll get into full-scale design. And it would take about 10 years before we would actually be producing water that could be reused. So probably the 2032 timeframe. And Genesis, are there any questions on this before I move?
No.
Okay. All right, so we kind of talked about how the water went through the plant, the blue portion here. Now I'm going to talk about the brown stuff, what we do with the solids. We send the primary solids and the excess sludge from secondary to the digesters. From there, it's digested. About half of it's broken down into gas, and then we reuse that in a power plant. We're completely energy self-sufficient here because we're able to produce so much gas. And then the solids from the digester go to centrifuges, where it's dewatered and then reused offsite. So again, as I said, we're actually treating the solids from the entire joint outfall system, so about 400 million gallons per day of flow. And the first step of the process are these digesters. You see about 10 or 15 feet above ground. There's another 35 feet below ground. These are 50-foot deep vessels. And we like to think of these as our 24 tummies, basically, that we have on site, because it's the exact same bacteria, microorganisms that we have in our stomach and gut that break down our food, and they're breaking down the solids for us. We have about a 15-day detention time to meet the regulations for reusing the material. And about, as I said, about 50% of the solids are broken down in these digesters. And it's an anaerobic process, just like the bacteria in your stomach. There's no oxygen in these vessels. This is a cross section of what it looks like. We heat these up to, believe it or not, 96, 97 degrees, same temperature as your body. This process kills pathogens, makes the solids easier to dewater, and also, as I said, produces gas. We have no moving parts inside for mixing. We use these draft tubes here, and then we have to clean these about every 8 or 9 years for any material that settles on the bottom. And then this is a view of the inside of a digester. As I said, these are huge vessels, about 125-foot diameter, 3.5 million gallon tanks. Just to give you a feel for the size of these, this board here is about 8 foot tall, so that can show you how big these are. You can see the draft tube over here, and there's lances that push the gas into the middle of the tube, and then as the gas bubble comes up, it creates a current, and that creates the mixing motion in these tanks. Okay, next I'm going to talk about what we do with the digester gas. As I said, we're energy self-sufficient. We use gas turbines in a power plant here. The gas comes in and is compressed with the air, and then there's a combustor section. It's very similar to jet engine technology. The hot gas comes out, the hot exhaust, that spins a turbine, which is connected by a shafted generator, which then creates electricity. And we've got 3 of these that can produce up to 9.5 megawatts. And we're able to save about $15 million a year by our power production. And I mentioned the hot exhaust. The hot exhaust gas comes out the back here through the heat recovery steam generator. It's a fancy name for heat exchanger. Basically, the hot exhaust boils water in tubes that then produce steam, and then that steam we collect and route to a steam turbine, and we're able to produce another 5 or 6 megawatts of power. Another use for our gas is in the boiler house. These boilers over here, we use low pressure. We produce low pressure steam with the digester gas, and then that's used as the fuel, and then the steam is used to heat the digesters. Another innovative thing we're doing here at the plant is we're producing some more energy with food waste, as it says here. We're taking food waste. You can see on the left here, it's pre-processed off-site, and then that slurry is brought here, and then we digest it. And then we have different uses for the biogas. We can, as I said, produce electricity, steam in our boiler house. We also have a biogas conditioning system where we clean up the digester gas, which is about 63%, 63% methane. We clean that up to about 95% methane and use it as a vehicle fuel in CNG vehicles. And then biomethane is something down the road we may be able to actually do pipeline injection of our gas that's produced. About 80% is converted to gas. The other 20% comes out the back end, and then that's hauled off site, and the majority of that is reused for compost. And when we talk about food waste, most of the residential food waste already comes here to the plant through the sewers, through your garbage disposals when it comes down through your kitchen sink. So when we're talking about the food waste that we're trying to divert from the landfills, the majority of this is commercial users, food processors, grocery stores, restaurants, places where they have a lot of food waste. We did a demonstration project with waste management, and again, you can see the unprocessed food waste here. It's processed with screens to remove the metals, plastics, glass, other things that are contaminated, and then we're left with this nice food waste smoothie here that the bacteria, microorganisms in the digesters love. There's a law out there here in California. It's called SB Senate Bill 1383 to divert, and it requires cities to divert organics from the landfill, basically food waste. It takes up space in the landfill, and they're hoping that by 2022, cities will have programs in place to divert that material. And then the cities are supposed to also, as part of that law, guarantee that they reuse the product, whether it's the gas or the compost. Some sites and cities are actually composting the food waste rather than doing it in the anaerobic digesters. So here you can see our food waste receiving station. This is where we can offload food waste. We truck it in, offload it to the tanks, and then from these tanks, pump it across the street into the digesters directly. We also have the ability to deliver food waste to the front of the plant and have it flow through the process. It's a little less efficient that way, but it does have the advantage of any residual trash or glass that's in the food waste gets removed in our grit chambers. And Genesis, before I move on, any questions have come in on food waste or anything else?
Yeah, well, on the solids, are the solids material coming in higher during certain times of the year, like after Thanksgiving?
Yeah, actually, surprisingly, during the holidays is when we have the least amount of flow into the plant. And that's because a lot of as I said earlier, about 15% of our water coming to us is from industries, and a lot of them are shut down on New Year's Day or Christmas Day, Thanksgiving Day. So we actually don't see an increase in solids. When we do see a big increase is during rain events where the sewers are flowing more full, the velocities are higher, and then there's a lot of scouring of any solids that might have settled out in the sewers or any grease that built up on the walls of the sewers. All that gets washed and flushed out during rain events. So we actually see a significant increase in solids coming into the plant during rain events.
And that was one of our questions. What happens if you get a heavy rainstorm?
Yep. So our flows, like as I said, our average flow is about 250 million gallons per day. Our peaks is normally around 300, but during a rain event, especially if we get one of those, Pineapple Express events where there's like 2 or 3 storms back to back to back, where the ground gets saturated and streets start to flood, we do get a lot of infiltration or inflow into our manholes, and we could see our flows, our peak flows, double up to the 500 to 600 million gallon per day range, and then an average flow over 300 million gallons per day. So yeah, rains definitely affect our process, and we're always trying to be prepared for those events.
Okay, cool. And switching up a little bit, do you accept all kinds of food waste or only vegetables?
We accept pretty much all kinds of food waste. We do have a specification that details all the various parameters that the food waste has to meet, such as pH, alkalinity, COD, things like that. So it's pretty extensive, but our solid waste energy recovery group is working with vendors, and if anybody works in that industry, they're welcome to contact them if they're looking to send food waste to us.
Yeah, and I also will say, if you visit www.lacsd.org/food waste, you get to our page that talks about the types of unprocessed food waste that we receive at our Puente Hills Materials Recovery Facility, and then also our slurried food waste, which we receive here at the joint plant. So I will put it in the chat. It's a really cool, there's a lot of great information. So if you're interested in food waste, please hit us up, as they say.
Yeah.
Okay, so next question that was going in line, someone had a question about what happens to, where are the biosolids taken and how is it used? And I think that's gonna be your segue soon,
Yeah,
right?
that's gonna be a
All right,
segue into
perfect.
the next thing here. Were there any other questions before I do that? Or?
No, I,
Oh, the other thing I'll just pile on with what you just said is for people, they can go to the tours page too, because we do have a tour on there for food waste that you can watch that too if you want more information about food waste. It's just specific to how they do the food waste.
all right, I'll put them both in the chat.
Okay. All right, so let's see here. So next phase of the process I'm going to talk about is solids processing after digestion. Excuse me. We pump the solids across the street to solids processing, and we've got 20 high-speed centrifuges there. These spin at 2,500 RPM, producing about 2,500 Gs of force. And this is very similar to the spin cycle of your washing machine. It just uses centrifugal force to separate the solids from the water. And we're able to go from about 2% solids content up to 29%. We do add a little polymer to help with the flocculation. But this is kind of what it would look like if you're able to look inside a centrifuge. The solids come out one end, and then the centrate comes out the other end. And then this is what the finished product looks like. It's we call it biosolids cake because it looks like moist chocolate cake. And we're able to take that, and then we have conveyor belts that take the material up into these storage silos. We have 18 storage silos, about 7 days worth of storage in case we need to store during a storm event or something where the mountain passes are covered with snow, things like that, or there's an earthquake where a freeway is blocked or things like that. But we have 3 truck loading stations. We're producing about 1,200 wet tons per day, so about 50 trucks per day, hauling material, the recycled material to be reused. And we have, as I said, the majority of it is composted, but we have a portion that goes to a landfill. And then also out here in this Denali site in Arizona, we do land application. And then there's a new facility that Energia has started up where they're looking at using the biosolids for energy production. And then we also have a compost site, Tulare Lake Compost. This shows the distribution. It's a very diversified program. As I said, in case there's any regulatory or economic issue arise at a site or site closes down for some reason, we don't want to have all our eggs in one basket, so to speak. And these are the facilities that the district owns. Westlake Farms, that's Tulare Lake Compost is the little purple square here. The biosolids are composted with wood waste from Kings County, and then it's used as fertilizer on Westlake Farms here. The Mesquite Regional Landfill, that's actually one of our solid waste facilities, and then that's a landfill that's fully permitted, and we'll have 100 years of capacity once all the landfill capacity in Los Angeles County is used up. But that could ultimately be a facility we might take biosolids to add moisture to the trash there. And then the last one is this Inland Empire Regional Compost Authority. That's a joint venture between us and Inland Empire for composting. And this shows an outdoor composting site. This is a Synagro facility where they compost wood waste from the Central Valley with our biosolids and then use it as fertilizer on the farms up there. This is the Inland Empire facility. This is actually a repurposed IKEA warehouse, and the composting is done indoors there. And the reason for that is because it's in the city and to control odors. This shows the land application site out in Arizona. Basically take dry fallow land and you add biosolids, which has a lot of nutrients that the plants like. As I've mentioned, it's got nitrogen, also phosphorus, iron, and then the crops they grow are cotton. As you can see, this is a cotton field. You can see the white spots here, but they also grow alfalfa on these fields too. Okay. Oh, were there any other questions before we move on, Genesis, on what we do with the solids?
No, you're good. I think someone just liked your moist chocolate cake reference.
Okay.
Yeah, we're good.
All right. So as I mentioned, kind of at the beginning, the Inlet Works, you see the screens up in the upper left here. This is one of our most odorous processes. And so we have something called our central odor facility. right here that pulls the foul air from the inlet works and treats it. So the next thing I'm going to talk about here is odor control. And basically, you know, this plant's been around here since 1928, and the community's grown around the plant. And we're always trying to be a good neighbor and trying to control the odors, especially at the inlet works. And also solids processing is another area we've identified that has a lot of odors. And, you know, if you're ever behind one of those trucks on the freeway, you pretty much know it. So we try and control our odors at solids processing as well as we can to keep them on, no odors leaving the site. So with that said, in the last 15 years, we've spent quite a bit of money to improve the amount of air that we're collecting and treating, and to minimize the odors. As you can see, we've spent over $70 million. And then to give you more information, just this past month, our board of directors approved another $2.5 million to improve covers that we've identified that need to be replaced because they're nearing the end of their useful life. So this slide shows, you can see the covers over here. These covers actually have gaskets around them to create a tight seal to keep the odors in. And then each tank, these are our primary sedimentation tanks. Each tank has a connection where there's a vacuum applied and the foul air is pulled off through these pipes and then into the odor control facility. And it's a two-stage process. We have large blowers. You can see the blowers here. They pull the foul air and route it through these what we call biotrickling scrubbers. It's a biological process where the biofilm grows on the media, and the sulfide that rotten egg smell from H2S, the sulfide ion, is then oxidized to sulfate, which is odor-free. So that eliminates that odor. And then from there it goes to a second stage process, which is a polishing process with activated carbon. And this removes any trace contaminants that we might have. We do have a number of refinery dischargers, so we might have toluene, benzene, vinyl chloride, things like that, volatile organic compounds that need to be removed before the air is exhausted to the atmosphere. Over at solids processing, it's similar. We have blowers that pull foul air. There's ducting here, fiberglass ducting that's connected to the silos and conveyor belts, pulls the foul air off and through the ducting to a biofilter. This is a similar technology, a biotrickling scrubber, except it's open to the atmosphere here. The foul air is pushed up from the bottom. These beds of media are kept moist and a biofilm grows on it. There's a lot of surface area, the biofilm grows. And then the bacteria, the microorganisms neutralize odors from ammonia and other sulfur compounds, complex sulfur compounds like mercaptans and dimethyl disulfide, things like that. As far as the media itself, we had originally started with wood chips, but we found that since these are organic, they break down over time and we have to replace these about every 3 or 4 years. So we've done some research and identified an expanded clay media that's a media that lasts much longer than the wood chips. And so we've gradually been converting to that type of media. And as I said, the trucks, that's very odorous process. You can see some of the cake there dropping into the truck as we load the truck. We try and keep the odors contained, and we looked at different options with doors and plastic sheeting and things to keep the odors in. And ultimately, what we found works best is the air curtains, which blow air here to create a seal to keep the foul odors in. Very similar to what you might see if you go to a casino in Vegas or out in the desert where the air is blowing down on the open doors to keep the cold, cool air in. So we use that same technology here. And I think the last thing I want to mention is, the cost, how much it costs to treat the water. And we're one of the most cost-effective large agencies in the country. As you can see in the comparison here with other cities, it's less than $30 a month. And that includes all your local sewer charges, as well as ad valorem property tax contributions. And to operate and maintain this plant, we have about 300 employees, and as far as maintenance and construction, mechanics, operators, engineering, and electrical and instrumentation, as well as about another 50 people that work in our water quality control lab, doing all the sampling and monitoring at all the various points of our process. So that's it for the formal presentation. I can answer any questions now, Genesis, if you've got more that have come in.
Yeah, so let me, hold on one second. All right, you ready?
Let me stop sharing here.
And and I'll put your contact information out as well, so we don't miss it. All right, so the most recent question just came in when you were talking about the biosolids and the media filters. Is this the most odorous area of processing?
Yeah, it's a different odor than the inlet works with that rotten egg smell, but yeah, it is. Those are the two most odorous areas: the solids processing and the inlet works.
Okay, cool. And we have a lot of questions about the Hyperion incident. A lot of people want to know what happened to the Hyperion plant. What was the problem there? Also, did that accident at Hyperion also happen at our joint plant? Is another question.
Okay. Yeah, somebody else just asked to share this. Thank you slide. So I shared that again, so you can get the information there. Yeah, I could tell you what we've heard. It's probably nothing more than what, if you've been following the Daily Breeze, they've been pretty good about every day. There's a new article there in the LA Times giving you an update. The city of LA does have a website set up now that you can go to. I think if you Google Hyperion, LA San Hyperion update, I think if you Google that, you'll find it. It's showing kind of what their current water quality parameters are that they're measuring on their effluent, and then also gives them an update on what processes are coming online. Just in a nutshell, basically what happened, or what sounds like happened, is they the inlet works, they have bar screens similar to what we have. Their screens are a little finer screens. I think they've got 4 that are 3/8 inch openings and 4 that are 3/4 inch openings. And, you know, those screens, you know, screen out any debris that comes in, whether it's, you know, mostly it's rags, but we get a lot of grease balls, wood, rope, basically anything that can fit through a manhole. You know, people sometimes use those as trash receptacles, unfortunately. But I mean, we've pulled mattresses off our bar screens. There was a time during a rainstorm where we had a bunch of potted plants washed into our bar screens. We were pulling those 5 and 15 gallon containers off of our bar screens. So, you know, a lot of stuff comes in, and especially, like I said, during the rain events, we get a lot of debris come in, and that's what they're designed to remove and to protect the downstream equipment. What was unique in this situation is it happened during dry weather, which was very surprising. And I think they're still investigating to see where it came from. And there's different theories out there. And I don't think anybody's heard anything conclusive on what it was. It may have been that they had some blockage in their sewer somewhere that freed up for whatever reason, and then came down as a big blob. But it would take many truckloads of material to plug up the screens. And that's essentially what happened. Their screens got overwhelmed, plugged up, started to back the flow up. They had a contingency plan to open a bypass channel to prevent the plant from flooding. But unfortunately, the bypass channel was in an area where it flooded before they could actually open the bypass channel or pull a stop log to allow the flow to go by, or open a gate. I'm not sure exactly what they have there. But it backed up, flooded the plant, and then that also flooded what we call galleries. These are like underground tunnels where, you know, we have them in our plant too, where underneath the sedimentation tanks, there's ports in the wall, and then a tunnel there where the pumps are, and that pulls the sludge off of the bottom of the tank and pumps it to the digesters. So those tunnels that they have, they filled up with water, and then so they weren't able to pump things off, and that's essentially what happened. They flooded about half their plant, so it was, and then they had to divert some flow through their 1 mile outfall near the beach for I think about 12 hours or so, and before they got the bypass channel open when the flow got lower in the early morning hours. So That's about all I know, unless somebody has a specific question.
Okay, we will move on to the next question also. And for everyone else on the line, please don't leave us. We have a very quick tour of our Bixby Marshland. It's a freshwater marshland that's right adjacent to the joint plant. So I'm going to entertain a few more questions before we move on to Basil Hewitt, our engineer, who's actually live from Bixby right now. So the other question, how does the size of your plant in Carson compare to Hyperion?
We're very similar. We're basically the two largest plants west of the Mississippi. I think their rated capacity is 450 million gallons per day. We're 400 million gallons per day, but our current flows are pretty close, and it's virtually identical technology. They use the high purity oxygen activated sludge with the cryogenic plants also for their secondary treatment. So very similar.
Okay, cool. So another question, do you compost the biosolids from sanitary too, or only food waste? Also, I'll put your contact information in the chat. So
okay, so I'll stop sharing again. Okay. Yeah, it's all of the solids. The food waste is a very small amount of what we're processing. Right now it's, let's see, it's probably less than 5%. It's a very small amount.
yeah, and then the next question is, actually this one's for Glenn Acosta, our project engineer for outreach for the Clearwater project.
Okay.
Glenn, question for you. Will the TBM be abandoned underground when it is finished?
So the TBM is about 780 feet long, about 2.5 football fields in length. It'll take about 3.5 years to go from the joint plant all the way down to the beach. And right before it gets to the beach, we're going to build a small shaft, and the small shaft will be used to take out the front end of the TBM. And then the whole trailing gear that is attached to it will be sent all the way back to Carson and removed from the shaft there. So that's kind of how the sequence will occur.
All right, cool. Thank you. All right, back to you, Steve. Are you seeing a lot more encampment debris like shopping carts, furniture, etc., coming through the screeners recently?
No, we haven't seen anything like that. I think it'd be real hard to get a shopping cart through. The manholes are only like 36 inches. I think the largest one is. So yeah, we do. I mean, I didn't really touch on it in my presentation, but the sanitation districts, we also have a stormwater group besides solid waste and wastewater. And one of the things they're really focusing on is to keep the ocean environment clean, is to try and divert some of the stormwater and clean some of the stormwater before it goes out to the ocean. Because every time we get a big rain event, there's just a ton of debris that's collected in the flood control channels and on the streets and catch basins and all those pipes, those stormwater pipes, that's a whole separate system of pipes underneath the road, and that goes directly out to the ocean. So people should be aware of that too. The stormwater does not go through any treatment plant or anything like that. So you shouldn't be dumping things down, changing your oil and washing it down in the storm drain or things like that, because it's going to the ocean, or changing your radiator fluid.
All right, great. So next question, is there any danger in using gray water for residential lawn/garden use?
There's always a risk when you reuse something like that, but it depends how you're using it and the procedures you're using, whether you're using the PPE or spraying it, or how, it depends on the specifics. Basically, I think the state has a website where they talk about some of the safe ways to reuse gray water or to collect rainwater and things like that, and use it in your home gardens and that.
Okay, cool. So next question, does San Francisco have a similar sanitation system?
Yes, they're a little more broken up than we are. We've got, like I mentioned, we've got the two large agencies here. We've got sanitation districts, and then we've got City of LA, and we each serve about half of the population. Up in the Bay Area, there's a lot of smaller agencies, but the biggest two, I think, are San Francisco Public Utilities and the East Bay Municipal Utility District. And they do very similar to what we do. They collect and treat the wastewater, and then they also have food waste programs for recycling the food waste.
Okay, awesome. So we have a lot of other good questions here about the drought, about microorganisms, but we're gonna take a quick stroll over to Bixby real quick, and then we'll answer the rest of those questions. But let me see, we have Basil on the line. So Basil Hewitt, he's our supervising engineer in the Public Information Office. He's live from Bixby, and he's going to give us a quick little tour about what's out there right now.
And Genesis, can you hear me?
Yeah,
Yep.
we can hear you.
Okay, so I'm going to try to do two things. Well, first, I'm scared. Yeah, I'm going to give a little history of Bixby Marshland. There you go. Can you see my screen now?
Not yet.
Oh, operator error. Bear with me, and it'll be quick. Okay.
Oh, and if you can, while we wait, if you can please, well, I'm sorry, I actually sent the poll out already, but
Go ahead, you can
if
send
you
it.
can please answer the poll. We're always looking for feedback. If you have any additional feedback, please email info@lacsd.org. I will also put that in the chat. If you have any good ideas or anything you'd want to answer for the next tour, please let us know, and we'd be more than happy to answer.
All right, Genesis, can you see my screen now?
Yeah, we can. If you can just close that poll that you got.
I'm making sure everyone take
The
all
poll.
right.
All
So
right.
you can see my screen. All right.
Yeah, we
All
can
right.
see.
Let's do this now. So we're trying to do two things out here. One, I want to give you an overview of Bixby Marshland.
I'm sorry. Could you hide your controls at the top, please?
Okay, that's
And your teams.
all right. There you go. So Steve's given you the overview of the joint plant that you see here, and the joint plant's in about 200 acres, and another 200 acres we use for buffer property. So right here, what you're looking at is Bixby Marshland, which is part of our buffer property. And this whole area used to be marshland, wetland. But with development, this marsh shrunk, and it's to a point where you just left a little sliver of a marsh. And so what is a marsh? A marsh is an area where water comes in, it's slowed down, and it's cleaned by the marsh, and it has a number of distinct ecosystem. It has an aquatic, I'm out in the parkland from Marshland, and we have folks that are here. And we're open from 8 to noon today, so hopefully you come by right afterwards. Yeah, so we have 3 different aquatic area, basically wet area, then the area right up on the bank, the riparian habitat, and then upland area, which is like meadows and trees. So with this marsh, it's very important for wildlife habitat. It's because of different ecosystem, a lot of different types of animals live in marsh, and they're being destroyed or shrunk. And so a number of years ago, we stepped in to rejuvenate, restore Bixby Marshland. And here's why they're important. Here's a pretty good schematic in terms of marshlands in general. You see water coming down. Some impurities that might be stormwater runoff settle out, and then the water may percolate in, and then the water goes towards stream or the ocean. So here's what we had in 1995. Not much of a mark. And the reason it got to this spot is that a flood control channel was put in. And so there was no source of water for this marshland. And you can see our facilities, it's right here, right next to it. So the district stepped in and we hired someone to help restore the marshland. Here's a schematic of what this firm thought up with our input, the community input. And the idea was to take water from the storm drain and pump it through this regraded area, and also put native vegetation back in here to create an oasis right here in the city of Carson. This is what it looked like after the regrading back in 2005, 2006, before the plants all started growing in. And here's another aerial of what it looks like now. So you see the storm drain right here where my cursor is at. And then the water is pumped in and meanders through. And so let's start with the parking lot. I'm literally standing in the parking lot right now, but I'm going to show you an aerial starting from the parking of what it looks like now. And this is our moment of Bixby. So you see the parking lot right here, and this drone is going to fly over the path, the walking path for guests. And today we've already had like 20 guests. And you can see the trees have grown in really well. And this whole thing is about 17 acres. A lot of birders that come out here, a lot of people who are naturalists. And then as you go to the path, notice this bridge. Oh shoot, yeah, I restarted it. So the drone is following the path that you would take as you walk through the marshland. Let's continue. It's pretty spectacular out here. And as we come up to the bridge, you can see the water that came from the storm. So this gives you an aerial feel of Bixby Marshland. And here's a different look. I want to point out, here's a road right here. Here's the storm drain, and there's a pump station that pumps water right into the marsh. That water gets clean, it percolates into the ground, and what doesn't percolate then comes back out into the storm drain, much cleaner. And you can see the bridge in the background. Pretty spectacular. You can see some birds playing in the water. And this was taken a couple of months ago when it was much cooler and more water in the marsh. Also notice in the back, the meadow type area, and the drones come back out, showing where the water exits the marsh. And you notice the storm drain to the right. And then this shows you the entry point from the storm drain of ground level shot, feeding the marsh. And a lot of creatures love the marsh. So here are mallards, duh. Each time you come here, you'll see something different. This footage was taken a couple of months ago during breeding season. Pretty spectacular footage that one of our docents took. You see different types of birds. Birders love it. This morning, we've had at least 5 different birders come in here with their cameras looking to spot different types of birds. Seeing hummingbirds here. And then we see different plants such as the California sage, purple sage. We've seen blue heron here. And that's all I got. There's a riparian pathway we'll walk through. And then we'll walk through some of the vegetation. I'm going to try to use my cell phone and give you a little taste, and we'll walk over to the bridge. That's all I have right now, Genesis. So let me see if I can.
Great. So you were going to walk through with your cell phone right now?
Yes, but you take questions while I get that fired
Do you want
up.
to take your Bixby questions or Steve's questions?
It's Steve's question.
Okay, all right. So Steve, you're back on.
All right.
Let's see, and then let me just stop sharing Basil's.
Yeah, stop sharing.
Very quick.
I'll
Okay,
turn
so
off my video.
all right. So Steve, if the drought continues, how will that impact your operation?
Well, as I said earlier, the biggest impacts to us are usually during rain events. So more drought actually makes it a little easier for us. But one thing we are keeping an eye on is even though there's people are over the past, I guess, 20 years, as we've done a lot of water conservation and added low flow shower heads, low flow toilets and things like that. You know, our flows used to be well over 300 million gallons per day. So we've dropped probably 20% in our flows. And one thing we've seen is that even though the water flow has decreased, we still have the same amount of solids coming into the plant. So we just see more concentrated. So we kind of keep an eye on that and make sure that we're still able to treat the solids and the digesters and secondary treatment with the biological process without having any upsets of the process.
Okay, cool. So the next question is, how do the microorganisms help? And do you have names or the types of microorganisms?
Yeah, I'd shown that one slide that showed it's mainly amoeba, flagellates, and but mostly there's a lot of rotifers. That's the biggest or best type of microorganism that we use out there. And then there's also there's bad microorganisms. We call them filaments. They're these long stringy type microorganisms that we try and set the conditions just right in that biological reactor with the right amount of oxygen and the right amount of solids, basically concentration, so that so we select out organisms that we don't like, that are going to cause us problems in settling. And it's kind of an art form to get the right mix of microorganisms so that they settle good in the clarifiers. So, and then in the digesters, that's a different type of microorganism, and the same thing there too. We try and keep the alkalinity, the pH, things like that, and obviously no oxygen, at the right concentrations, the right environmental parameters, so that we can optimize the best organisms there too. Right temperature. We don't want to be too hot or too cold, things like that.
Cool. And someone has a question. Kevin says, just for clarification, I've heard of primary, secondary, and tertiary treatment at some plants. In the process at LACSD, is it just one round of biotreatment with the digesters and bacteria and then straight to the digesters?
Yeah, so our plan here, we have primary treatment and then the solids that come out of primary treatment to settle there, they get to the digesters. We also have secondary treatment and then there's microorganisms there. And just like you or me, if we're eating all the time, feeding on things, we have waste products that come out. We don't just bloat up into 1,000 pounds. So we're always wasting. So the same thing with our biological process at secondary. We waste out probably, a certain number of tons a day, 100 tons a day that's wasted out to the digesters. And then, so we've got the primary and secondary solids go to the digesters. And then we disinfect and go out to the ocean. What the person's probably asking about is, I had mentioned at our water reclamation plants upstream, they kind of cherry pick. They don't get a lot of industrial discharges up there, so they don't have the high salt content in their water. And so they're able to then take their secondary effluent and they have the same thing, a primary treatment and a biological secondary treatment. And then they take that secondary effluent, run it through sand filters for a polishing step to take out any other miscellaneous things, small, basically flock particles, less than 5 milligrams per liter that they take out. And then they're able to reuse that in irrigation water and groundwater recharge up there. And then they also, in their secondary process, they run with a longer sludge age for the microorganisms so that they're able to do what's called the NDN, which is a nitrification denitrification process to convert the ammonia to nitrogen gas and remove it from the water.
Thank you. Is it cheaper to make drinking water from sewage than from desalination of ocean water?
Yes. And the reason is because even though we have a high salt content, we're still significantly less than ocean water has much more salt. And so you need a lot more reverse osmosis modules and pressure to remove that. So it is more costly to desalinate seawater, ocean water, than it is to desalinate the wastewater or the final effluent that we have.
Okay, and
Dennis, can I break in for a second? Yeah, I just wanted to show folks the parking lot of Bixby Marshland. We have people kind of cycling in the whole morning with a sign-in table. We've had probably about 20 people cycle in since 8 o'clock in the morning. Go ahead, back to your question. I'm going to walk over to the bridge.
Okay, we just got one more question for Steve, and then we'll get to you. So last question for you, Steve. Speaking of gray water, is it legal to divert household non-toilet water to your yard?
It depends on the city, I believe. You're going to have to check with your local city regulations, or if you're in an unincorporated area of the county, check with the county.
All right, cool. Actually, another question. So in Western Avenue has been settling in places sinking for decades. And there's sometimes odor on Western and Rancho Palos Verdes. Could all that be from old leaky tunnels? And do those get repaired or shut down?
Yeah, if they've got the odors, and I probably forgot to mention that if you ever have odors in your neighborhood, feel free to contact us. We're very proactive about going out in the neighborhoods and checking. Especially as I said earlier, we've got 1,400 miles of collection system. So, thousands of manholes out there, and we try and keep them all sealed up to prevent odors from the sewers from coming out into the neighborhoods. But, we also actually on a lot of manholes, we've outfitted them with these carbon canisters, activated carbon on the underside of the manhole lid so that we're able to keep the odors from coming out into the community there. So if anybody does have odors in their area, please contact us and we'll try and investigate and see where the odor is coming from, if we can identify the source. And if it's from us, definitely we'll seal up our manholes and take care of it.
Okay.
But the two existing tunnels take secondary effluent, which is basic. It looks similar to tap water. So no odors should be coming from our.
Yeah, there's
tunnel.
no, Basil's absolutely right. There's no odors from the tunnels there. In Western Avenue, there are sewers that run down through that area. So my guess is it's a sewer odor, but somebody would have to go investigate. And yeah, Genesis just put in the chat where you can report the odors too.
Awesome. And just one question, is Pasadena part of our system?
Yes.
Yes, they are.
Yep.
All right, so Basil, please lead the way. We are ready for you.
I just wanted, I'm using my cell phone and I'm at the bridge, and I don't know if you can see that in the background. Genesis, can you spotlight my video or?
Yeah, you're spotlighted.
Okay. There are two egrets in the foreground. So we got luck. Every day you come to or you see something different. Earlier in the year, we saw Canadian geese. We've seen cormorant, and there's a pair of egrets that have been breakfasting here this morning. Can you make that out, or it's too far?
It's pretty grainy.
Yeah, stop. If you can hold your camera still, maybe it'll.
It looked great earlier, but now it's a little grainy. And you're frozen.
Oh shoot. Can you hear me?
Yeah, we can hear you. Yeah. Hey, Basil, I have questions for you.
Okay.
Are there a lot of mosquitoes in the marsh?
No, because there are mosquito fish. Like if I was using something beyond my cell phone, you would see the mosquito fish in the marsh. I'm gonna, so if you could look, the mosquito fish, and Steve can answer that as well, are put in the standing water in the marsh, and they just so they keep mosquitoes under control. I think I have more mosquitoes in my backyard than here at the marsh. Steve, do you have anything to add about the mosquito fish? How often they're put in here?
Yeah, as you saw in the video, there's the open water areas, and there's mosquito fish there, and then the one area where we try and address mosquitoes is in the tule beds, because it's hard for the mosquito fish. If the tule beds get too thick, the mosquito fish can't swim in there. So we actually do maintenance every fall on the tule beds to try and thin them out so that we can ensure that the mosquito population stays down.
Okay, cool. And next question, how do you prevent too much water from getting into the marsh during periods of heavy rainfall?
The way the marsh is designed is it actually can have a flush through when that flood control channel runs full. Besides the little pump that can feed the marsh, there's a 36-inch pipe that can flow water directly into the marsh from the flood control channel if the elevation gets high enough. And so during storm events, it can flow in and flood the marsh area. But there's also, as Basil showed on the outlet side, there's an outlet on the back end. So it'll never get higher than the height of the flood control channel.
That's cool. That's an interesting fact. Another question, is the Bixby Marshland the same as the Madrona Marsh and the Henrietta Basin?
No, they're different.
Go ahead.
Madrona is over in the city of Torrance, and actually I'm not even familiar with Henrietta. Basil, do you know where Henrietta is?
I'm not sure, but I know when we clean up the stormwater in the storm drain here, it benefits Madrona Marsh because it heads downhill, down gradient to that area. But I'm not sure where Henrietta is.
You know, I looked up Henrietta Basin and it's in Torrance.
Oh, actually, yeah, you're right.
Steve is the Torrance resident, so.
Yeah, it's like half a mile from my house, I think. So,
yeah,
yeah, the Henrietta Basin, and I think over there they also have Entradero Park is a basin too. So there's different basins for stormwater to prevent flooding in Torrance in various areas. Those are all upstream, and Madrona is also upstream of us. And then what flows downstream, where we flow downstream into, is Machado Lake, which then flows out to the ocean.
Okay.
Can you see my screen, Genesis, at all?
Yeah, we can.
Do you see the bird flying, the egret, the snowy egret?
I don't really see.
Oh, white speck fly across the screen.
Oh, yeah. Yeah, we have like 3 snowy egrets in the marsh this morning at the wetlands.
Do you have your little MiFi there with you?
Yes, I do, and I'm not
Oh,
sure why
okay.
it's not.
Okay, yeah, that's a shame. It's usually, oh, someone said they saw the egrets. So cool.
Oh, okay, great, great.
Awesome. All right. So we're good. Um, all right, great. So also we have a few other questions that are coming in. Meanwhile, is the sanitation districts also involved in processing recyclables?
Yes, that we have in our solid waste group, they have a material recovery facilities, MRFs they call them. And
Yeah.
we've got one in Dart, which is in Downey, which is in Downey. And then we have one at Southgate, and then our largest one is up in Whittier, our Pointy Hills Material Recovery Facility. And they have a sorting line there, which separates out the recyclables. And again, you can go to our website, and there's tours on that also that have been recorded over the last year. And actually, we also have the YouTube page. I don't think we mentioned that yet either, but
I put it on the chat. But yeah, the Point Hills Materials Recovery Facility is really, really cool. We have a new automated sorting line that's very effective in source separating all the recyclables. So it's really cool. You can go, well, I'll put the link again just in case anyone missed it, but you can go to our website and learn more about the type of recyclables we take in. We also have a free paper shredding at the Point Hills Materials Recovery Facility. And you can check out our tour. It's really, it's great. I did give the tour, but so I'm not.
you know, it's awesome.
It's great. Yeah, a little biased. Anyway, so someone has a question. Does humid weather impact the odor? Because they said lately it's been very humid in the San Gabriel Valley. The odor has been bad. Do you know if that's has anything to do with us?
A lot of it depends on the wind, how much wind and dilution essentially you're getting. So if it's more still and everything's just kind of sitting, it tends to be more odorous. If there's not much wind. The other thing that we've actually seen on one of our when we were investigating, somebody had called with an odor near their plant. We went out and investigated. It actually turned out that because it's been so humid this past month, which is kind of not normal for Southern California, we found that they had been over irrigating their yard, and it had kind of gotten kind of marshy, septic, swampy smell to the yard because there was so much like standing water in an area of the yard. And so you can have that happen too, where if you have wet areas that can go anaerobic and have that kind of funky smell.
Oh, that's crazy. So yeah, there are always different reasons. Okay, Basil, back to you.
Yeah, I'm just showing you some of the folks here and enjoying the marsh. It's a pretty leisurely morning. You see birders with their cameras. I had an egret. I need to invest in a camera, cell phone with better zoom
It's not that. I
capability.
think it's probably the reception there right now,
Yeah,
because it's been great
low.
other times. But anyway,
Yeah.
was there anything else you wanted to add, Basil, before I wrap up?
No, I think we're good. Just come on down. The marsh is open till noon today. It's open first Saturday of the month from 8 to noon. We have docents here to give you a guided tour. There are benches here. Little kids come in, families come in, and it's a way to socially distance while experiencing a bit of nature. That's all I have.
And I hear it in the background. It sounds like a lot of fun.
Yeah,
Sounds like you're at
everybody spread
Disneyland.
out. Yeah.
Sounds like Disneyland in the background. There's cool.
Yeah, one thing I would add too is this time of year it gets a little more dried out, and there's a few birds out there and stuff, but there's really a lot of birds out there in during the nesting season and in February, March, April, May, and a lot of water there. So that's really a good time to come too.
Yeah, you'll get some great photos. I've seen, yeah, for when you have your little special cameras, I've seen people taking those photos out there. So, okay, with that, thank you everyone for joining us. I hope you had just as much fun as we did. Thank you for your great questions. And if you have some free time, please come join us at the marsh. We have a blue heron, I think I saw, the snowy egrets, and there are a lot of other birds that come by. And if you have any questions, feel free to send us an email and I'll send them all to Steve. So info@lacsd.org. And that's it. Please let us know if you have any other questions. And thanks again for joining us. We hope to see you on the next one. Bye, everyone.
Everybody.
Bye, everyone.